Hey, what's up, guys? Welcome to a brand new episode of the Clear to Send podcast. Actually, a brand new year of Clear to Send. So happy new year. Happy 2021. I hope you had a great transition into the new year as best as you could during this pandemic. But in this episode, I want to talk about 802.11r or Fast BSS Transition from the CWAP perspective. So if you're taking the CWAP exam this year, you're studying for it, then this is a topic we're going to dive into in this episode. My name is Roel Dionisio. I'm your co-host here. Francois Verges is unable to join me for this episode, so it's just going to be me solo talking to you. One thing before we get started here, I want to ask you to fill out our annual survey, which will help us understand what kind of topics that we should be preparing for the episodes that we publish every week. If you head over to cleartosend.net/survey, it only takes about 5 minutes where we ask you some questions about the show, what you would like to hear or see on our YouTube channel, and as well as on this podcast. And then we ask some questions to learn more about you, our listeners, because we want to try to tailor that content to you guys so that the material that we're publishing is relevant for you. And I know there's a lot of people who want some deep dive topics, so hopefully this kind of responds to that in this episode. If you want to follow along in this episode, I do have the PCAP files available for download. These are the ones I'm going to use speaking to you in this episode. If you go to cleartosend.net/251, you'll find the files there as well as the show notes for this episode too. And I'll include some details, some screenshots, and again, follow along, download those files, and we can talk about 802.11r. Now, in the past, we have had an episode about 802.11r. That is episode number 198. You can listen to that over at cleartosend.net/198. This episode is going to be a little bit different. We're going to specifically dive into the frames and try to talk about this from as an objective for the CWAP, kind of tackle the subject there so we can prepare you for that exam. Again, so head over to cleartosend.net/251 for the show notes and the PCAP files. And so let's begin talking about 802.11r or Fast BSS Transition. And this involves a device that is currently associated to an access point. We'll call that AP1, and it want to moves or roam to another AP. So from AP1 to AP2. And in that process, we want to try to minimize some of that time it takes to transition, to roam over to that new access point. It's final destination access point, AP2. Without 802.11r, what would happen is the device would try to look for another access point to join, probably because the signal, its RSSI, might be weak of its currently associated access point. And so as it finds a new access point, it just does the whole authentication and association request again to that access point. And then it also has to go through that four-way handshake, all the security frame exchanges, etc. Right? And so without 802.11r, that could take some time. You could find some latency there because of that roam. And so the purpose of 802.11r is to have this fast transition or have this fast secure transition. And so what I want to do is share my screen and talk about the frames itself. And so if you're listening to the podcast, I will be as descriptive as possible. If you want to follow along visually, you can head over to our YouTube channel and check out this episode under 251. So in this example, I'm going to be using one of two PCAP files. And what I have here is a capture that I've done with my iPhone connecting to my my Cisco access point. And so we see that authentication and also the association requests, and then you'll see all of these exchanges. So you'll see the four-way handshake. And in this test, I'm trying to replicate or try to recreate a reassociation, because in the 802.11r, the Fast BSS transition, we're trying to do a reassociation, right? So you'll see a reassociation request and a response. So in this PCAP file, you see my four-way handshake there, and the BSS ID of the access point that is in question, right? So if I expand or click on, let's just I'm gonna click on the association request, the first one that my device is trying to associate to. And if I look at the information here, I'm expanding all of these fields. Actually, I expanded too many, but in the association request, you can see that I have my source address, which is going to be my radio of the client, the device, and then the destination address of the access point in that association request. So I just want to make you guys aware of the initial access point. The MAC address ends in E5EF. And so we have that association that occurs. And as my device wants to roam to another access point, it then does a probe request or a probe request to the new access point. And in this case, we see that the authentication goes to a different destination BSS ID, which ends in DE6F. And so as we're looking at this, some of the things you want to notice in these frames, and if we look at the association response frame, I'm going back to the first one. And so that what I just told you was the first AP and the second AP. Now, when I'm looking at the details of this association response from the access point, I'm going to expand wireless 802.11 wireless management and also the tagged parameters. And so what I'm looking for here is this Fast BSS transition that we have here in the actual frame response, right? So we have these PMKs that are derived here, but specifically, I'm looking at the mobility domain information element as well. And so in this mobility domain, we could see that we have whatever the fast transition capability is on this extended service set, right? And so there's two kinds of methods for fast transition that we're going to go through. And those two could be over the air or over the DS. And DS is going to be your distribution system, or the other way to put it is that could be the network where all of your BSS connect to, or your ESS. So that could be your controller if you've got a controller-based network, or that could be your network with all your switches because maybe you're using a cloud-based wireless system. And so right here is where I'm looking at for the mobility domain information element. You can see the tag number and the mobility domain identifier. And this identifier should be the same across the access points that are participating in that same mobility domain. They need to be the same for fast transition to work properly. And so you can see if you are using over the air or over the DS, if you expand the mobility domain information element, and then you can see the fast transition capability and policy, and whether or not you're using fast BSS transition over DS, it will be 0 if you're using fast transition over the air. And so this is this frame that I'm looking at here is an over the air frame or method that is going to be used. So now if I look at, I'm going to scroll down into the list of different frames I have in this capture. And you can see I have a 4-way handshake that occurs. And after the 4-way handshake, I now see like this new probe request and response. And this is coming from AP number 2, because now my device is going to start roaming to a new access point. It wants to roam to a new access point. So in this, when this happens, you see this probe request and then a probe response from AP number 2. And then you start to see the authentication and reassociation request. And so this reassociation request is the key part for your Fast BSS transition. What I can see here is that the source address, again, is going to be my device, my device over the air. We're talking about the over the air transition. So the source address is going to be my device, in this case, the iPhone. What's really neat about over the air is when it wants to do Fast BSS transition, it's going to communicate with the destination, the target access point, directly over the air. And so as the device has already created that frame exchange and authentication with the current AP, when it roams, it's going to send its authentication frames, the probe request and the authentication request frame, directly to the target AP. And when that occurs, the target AP is going to respond directly to the client. And so when you start looking at the information elements, yet again, you're going to look for the mobility domain information element, and you can see that the identifier should be the same. And also the other element for Fast BSS transition over DS will be 0, meaning this is an over the air exchange. And so that is the key difference between over the DS, or the distribution system. In the over the air distribution system, we have a different way in which the device communicates with the target AP. And so what I have here is my other capture where I show over the DS. So it looks very similar, but when we look at the actual transition here, and this is with a Mojo Networks AP, we see a probe request first to the initial AP, the first AP that it connects to. And as it roams, it'll do another probe request looking for another AP. But over the DS means that the communication to the target AP is going to happen from the current AP that the client is connected to. And so what you'll end up seeing is an action frame. And so this action frame is going to be, if we expand the information elements again, we will see that the source address and the destination address here, but in the action frame, there's going to be a mobility domain information element. And again, the mobility domain identifier should still be the same. But we then see that Fast BSS transition over DS is enabled. And so now if we look at Fast BSS transition from the DSS point of view, the DS point of view, the distribution system, this is the key difference. And then those frame exchanges occur through the AP initially, those action frames. And then after that the reassociation request frame, that will come from the client to the target AP, and the target AP responds with the reassociation response frame directly to the client. All right, so let's take a look at the differences between the two. In the first example, which is the over the air, that frame when the client device wants to roam, do that fast BSS transition to the target AP, over the air, that device will source its frame, its reassociation request to the target AP, and that target AP responds directly to that client. In the over the DS, the client will send its initial request, the fast BSS transition, to the current AP that it's connected to, and then that AP forwards that request to the target AP. It is then with the reassociation request is when the client will then send it directly to that target AP, and the target AP directly replies to that client. So those are the differences between the over the air and the over the DS. If I go back to the over the DS, I'll show you the action frames and the destination MAC address, because if we look at the initial request to its current AP, the BSS ID ends in 73C0. When the client device wants to do that fast BSS transition over the DS, you can see that the action frame from the device is sent to the currently associated AP, ending in 73C0 for the BSS ID, those two action frames. And that's because the AP will send that action frame over the DS to the target AP, and the response will come from that current associated AP. And then when the reassociation request occurs, you'll see that the device, my iPhone, then directly sends a reassociation request to the destination address of the target AP, and that BSS ID is CFD0. And so there you have the difference between the two. Now, if you're wanting to capture the same frames, the same way that I'm trying to do this, the way I was able to capture this frame, I think there's a couple ways you can do this. You could use Air Tool on the Mac, and you want to capture close to the client. And so you're going to have to capture on two different channels, or if the APs are on the same channel, then you only capture on that one channel. But in this scenario, I have one AP on one channel, the target AP on another channel. And so I'm capturing on two channels. And you may have a couple of times you have to try to do this because you're trying to capture all of the frames necessary. So you can use Air Tool to do that. Or you can have two devices capturing on each channel. So you have one device capturing on the first channel where you have that initial association, and then you have a second device that's capturing on the channel where the target AP is operating on. And that way you can capture more efficiently that way, because you don't have to worry about the dwell time when you're capturing on two channels with one device. But then you merge the PCAP files, and then you'll have everything in a single PCAP file. The other way you could capture this is the way I captured it, was using the Ekahau Sidekick, and using the capture utility. I set the Sidekick to capture on two separate channels, and then was able to see all of the frames that I captured. So those are the two methods I wanted to dive into when it comes to the fast BSS transition, fast BSS secure transition, specifically the 802.11r, as I've tried to analyze it. And the key things here again are the mobility domain information element. You'll want to look at to make sure that it is the same value, the same tag that's being used. That is the mobility domain identifier, because if they are not the same on the APs, then that fast BSS transition is not going to occur. And then looking at the fast BSS transition over DS and see what that marking is. If it is a 0, then we're talking about an over-the-air fast BSS transition. If it is a 1, then you're looking at a Fast BSS transition over the DS. So head over to the show notes if you want to take a look at these captures that I have here as an example, and spot the differences yourself. And then you could use that as part of your CWAP studies if you want to get the book itself. I'll also link out to the book if you're just going to get started with your CWAP studies. So that is the episode that I wanted to create here for you guys. If you have any questions, head over to the show notes, cleartosend.net/251, and leave a comment there in the show notes. Or if you're watching the video, you can leave a comment down below. Other than that, I hope you guys are having a great start to the new year. I think CWAP is going to be a great exam for you to get and really dive into the frames, because it's how you're really going to understand how Wi-Fi works, especially with these frames being exchanged over the air, and then diving into all of the different information elements. That's what the tricky part is trying to understand what each and every one of those information elements does. I'll also include a filter, so you can filter out the PCAP and see what exactly the frames you want to look at when it comes to what I just mentioned here on this episode. But thank you again for watching or listening to this episode, and I'll see you on the next one. Bye, guys.